Greetings and welcome, friends! Me and my algebra buddies going over some solving equations, multi-step variables on both sides. Here's question 16, and first thing we should do is simplify. I'm going to do some distributing here. Also, this 12 that's being distributed, I want to point out that minus sign is coming with it. All right, so that minus sign is going to be passed along that set of parentheses as well. So follow along, friends who are local here. 8x plus 4. So yeah, write down corrections if you get anything wrong, or if for some reason it was blank. Right, you can add that. Negative 12 times x is negative 12x. Negative 12 times negative 1 is plus 12. And let's combine like terms over here, right like that. So this side's still the same, 8x. Here, guys, follow along, we're doing this. 4x minus 12x is negative 8x's plus 12. Now let's bring these x's together. Who is the little guy of those x's? That doesn't have an x. The negative 8x, so I'll move that negative 8x to the other side by adding it to both sides. So I get 16x plus 4 equals 12. And I realize, yeah, negative 8x and 8x combine to be 0. But I just kind of shift this to the side since those got destroyed. Now what do I do? How do I get x by itself? Yeah, subtract 4 from both sides. I wanted it to be 16. Yeah, I wanted it to be 16 as well. Yep. And I'll have x equals, now 8/16 can reduce. What's a number that goes into both 8 and 16? 2? Anything better? 4? Anything better? 8. 8 goes into 8 one time. 1 does go into it as well. And into 16 twice. So I'm going to get x equals 1/2. All right, so that was, notice, how many solutions does this problem have? One solution. There's one value that could go in here and work perfectly. Let's take a look at this one. Ooh, movies. The equation 15r plus 15 equals 2.25r represents the number of movies R. Why is it R? Oh, for rental? Man, people don't even rent. Oh, I guess there's Redbox. Yeah, what was that? I just corrected myself. The number of movies you rent to spend the same amount of money at each movie store. How many movies must you rent to spend the same amount at each? So notice that the amount you spend here would have been your $15 plus $1.50 times the number of rentals. And this one, there's no membership fee, but you then have to multiply the price per rental times the number of rentals. They set those two things equal to each other. Oh, I'm missing an R there. Because we're interested in when will they be the same, right? When is Movie World in Video City gonna charge me the same amount for the same number of movies, right? So let's see. To solve this, let's bring the R's together. Who is small r? 1.5r or 2.25? Yeah, so I'll subtract 1.5r from both sides. Bless you. And I've got 15 equals, what's that, 0.75r? Is that right? And then how do I get rid of that 0.75? Yeah, because it's being multiplied, and the inverse operation would be divide. 0.75, 0.75. And so I'm going to get, what is it? 20 is correct. So I get 20 is equal to R, or R equals 20. Now, let's answer. Right, so I'm going to say 20 rentals, 20 movies. right, is what it takes for each movie store to charge you the same amount. Now, what if I followed up with, what is that amount? How much do 20 rentals cost? And what I could do is take this 20 and plug it in either this side and evaluate it, or I could plug it in this side and evaluate that. Either of those are going to give me the same thing. So let's see, 20 times 2.25, what's that going to be, $45, I think? Is that what it is? 2.25 times 20. Yeah, $45 is what it actually costs to rent those 20 videos. All right, let's keep moving. Guys, did you know that some problems just can never be solved? Yeah. And some problems are just like impossible to not solve. They just have infinitely many solutions. And that's what we were analyzing here. I chose kind of the weird one with fractions. But let's see what I did for 24. So you guys are tracking with me here, right? You're tracking. So I'm going to start by simplifying both sides by distributing multiplication over addition and subtraction. That's good old distributive property. So Devin's writing this down. 5 times 1 is 5. Plus 5 times 2 is 10. 10m. Half of 8 is 4. And half of 20 m's would be 10 m's. Right? Oh, dear. And then when I try to solve, I'm subtracting 10m, Ethan, from both sides. 10 a.m. And I get, that's nothing. 5 equals, those m's cancel out, 4. And does 5 equal 4? Nah, that's false. And because that's a false statement, and my variables all disappeared, we end up making a conclusion that this problem has no solution. Yeah. Ain't nothing we can do to make this problem happy. Nothing's gonna work. Cameron, you writing this down? Looks like you're like absorbing this through osmosis. All right. Oh, no, we didn't. A cheetah that is running 90 feet per second. That's a rate. Ooh. Guys, so first of all, I want to point out that rate times time equals distance. All right? And is 120 feet behind an antelope that is running 60 feet per second. Oh, dear. Oh, dear. How long will it take the cheetah to catch up to the antelope? So, I think I set it up like this the other day. Cheetah, antelope. All right, I'm just going to make like a little table for each of these components. So for our rates, gentlemen, track with me here. So for our rate, the rate of the cheetah is 90 feet per second, right? Yeah. The rate of the antelope is 60 feet per second. Question, comment? Yep, FPS, first-person shooters, a wonderful genre of videojuegos. Let's see, time. They're asking us how long it'll take for them to catch each other. That's going to be my variable. That's one of my variables for sure. So time is unknown to us, but it's measured in. What do you think the time's going to be measured in? How do I? Minutes would have been a good guess, except these are in feet per second, so we'll use seconds. All right, so time is just going to be t measured in seconds, right? And that time is going to be the same for both of those. And then for their distances, let's see, what's another color I should use? I guess I'll use red this time. The distance of the antelope, if the distance the antelope runs in that time is d, what's the distance that the cheetah needs to run? Or, let's see. What do I have to set this up as? He's 120 feet behind the antelope. Yeah, so I think I need... I'm thinking this through here, Ethan. I know you are too. I think I need to write D minus 120? Or is it D plus 120? It feels like plus, but I'm trying to think of how I'm going to translate that into the equation in the end here. Because I'm just thinking through variables here. I know he's going to be running 90. Or actually, it's probably a she, right? I don't remember. Cheetahs. So 90 times S. I think, yeah, minus 120. When is that going to equal 60 times S? Because, yeah, he's 120 feet behind. Yeah. Yeah, Cheetah's running faster for sure. But let's find out how long it takes for it to catch up. So to solve this, what do you guys think I do? Yeah, I'd bring a little guy to the big guy. Well, here, wait for this one problem if you could. If you're able. Yeah. So I'm going to have 30S minus 120 equals... Uh-oh. What's the mathematical number for nothing? Yeah, there you go. And then how do I solve this for S? I would add to both sides. So I'd have 30S equals, lining up those equal signs, right? 120. Cameron. I. And then to solve for S, it's being multiplied by 30, so divide both sides by 30. Man, this thing's fast. S equals 4. How did I get S? No! Ah, crazy Mr. Waddy. I wrote S for my units. I was supposed to use the variable T. That's fine. Meh. We could just pretend all of those were T's the whole time, but you don't have to. T, T, ta, T, T, ta, T, T, ta, T, T, ta, T, T, ta. There you go. So I get T equals 4. What does that mean? That after 4 seconds... Yeah, the cheetah catches up, right? After 4 seconds, the cheetah's gonna have seconds. No, okay, never mind. The cheetah will catch up. The cheetah's chasing the antelope, not the t'other way around. All right, so thanks for watching, internet friends. Have a great day.